Good morning, welcome to EEPROM Toast. Today we have a simple tutorial on how to read hexadecimal. Let's begin. Introduction to hexadecimal. As the name suggests, hexadecimal is 16 bits. Hexa means 6 and deci means 10. Just add them together and you get 16. Hexadecimal is denoted by 0x. You will know a number is being represented as hexadecimal when you see 0x, for example, 0x1a is 26. 0 through 9. In hexadecimal, the decimal numbers 0 through 9 are represented as their normal values. For example, 1 would be 0x01, and 9 would be 0x09. 10 through 16. This is where some people will start to get confused. So when we write 10 in hexadecimal, we will write it as 0x0a, the a being 10 and f being 15. Just fill in the alphabet going up to f, like a equals 10, b equals 11, c equals 12, etc. When you get to 16, it will be represented in hexadecimal by 0x10. Rinse and repeat. 0x00 to 0x1f, 0 to 31. Let's cover how the hex values roll over. Obviously, we're going into the first 32 bits, not the first 16, because it's me. 0 through 31, the first 32 bits. 0 through 9, as we covered, excuse me. As we covered, the first 10 bits are represented in their normal decimal value, 0x00 being 0 through 0x09 being 9. 10 to 15. When counting the 11th to the 16th bit, we will use the letters A through F. 0x0a is 10, 0x0b is 11, 0x0z 0x0c is 12, 0x0d is 13, 0x0e, this is supposed to be an E, I accidentally put a D, but it's an E. So 0x0e, as in echo, is 14, and 0x0f is 15. 16 through 25. At the 17th bit, it resets itself in a way. Remember, we are counting 0 as the first bit for those who are confused. So 0x10 would be 16. And we just apply the same rules for 0 to 9. 0x11 is 17. 0x12 is 18, etc., etc. Now, what I'm trying to cover here, and I'm going to take a break from this for a second. I know I'm sort of like straining myself. My eyes are actually kind of strained from reading this, but what I'm trying to cover here is how the numbers sort of roll over, and once you get the fundamentals of the first 16 bits, you can just apply them to the rest of reading hexadecimal, just like anything else. I don't know, I picked this up way too easily, way more easily than I thought I would. But here we are, I'm here to share. Now let's move on. 16, 26 to 31. In an effort not to sound like a broken record, I'm going to keep this one short. 0x1a is 26, and 0x1f is 31. You figure out the rest. Just like regular decimal, the numbers keep rolling over to infinity. Once you have the basic pattern down, you can officially read hexadecimal. Now let's try something interesting. Let's try some math. So, 0x10 to 0x10 minus 0x0a. If If you need, feel free to reference the XC table. Also feel free to pause. Me personally, I don't see the need for the XC table for this anyway. There's probably some people who find it useful. A lot of people probably find it useful. I prefer to just commit this stuff to memory, and I think it's best that people do the same. But I don't know, who am I to talk? Got your answer? Alright. And this one would be... this one would be 6. So, remember, 0x10 is 16, and we're subtracting 10, 0x0a. So it's 6. Now, here's another simple one. Hopefully none of you are confused yet. 0x1a plus 0x04. Now, remember, you can pause the video if you want, try and solve it on your own. Alright. Remember, 0x10 is 16. So with 0x11 being 17, 0x12 being 18. So 0x1a still confuses me a little bit. Hold on. So 0x1a would be... Not even looking anything up. I don't care to look it up. I'm just having a brain fart moment. Zero x1a would be 26. Remember, 0x10, 16, plus, obviously, you count on your fingers, and so this would be 30. This is what happens when you don't sleep right and you don't drink your coffee. Oh well. Okay. 0x20. Of course I did. Minus 17. Let's mix it up a bit and subtract a decimal value from a hexadecimal one. Okay. 0x20. So if 0x10 is 16, 0x20 is 32. Now 32 minus 16 is 16, minus 1 is 15. So 0x0f would be your final answer. 0x28 minus 20. So we know that 0x20 is 32, and the next 16 bits, or 0x30, would be 48. 46 minus 20, 26. I have not slept well, and I haven't had any coffee yet, so please excuse me for suddenly not being able to do math. A little outside of our comfort zone. It's alright though, pain is just weakness leaving the body. And 0x30 plus 16. Seems scary, but this is the one that's in most of our CPUs, okay? It's 64 bits. 64. Well, I can't call it 64 bits, 'cause it's a 16-bit number. But the value of 0x30 plus 16 is 64. Alright. This one is in most CPUs these days, unless you're some Windows XP using cretin. Yeah, I'm looking at you, Vladimir Putin, and your stupid Windows XP computer. Fuck you. Anyway, here's your XC table for anyone who's interested. Not that you fucking need this thing, really, although binary looks pretty fucking confusing at first. We'll touch on that on this channel one day. Alright? Peace. And remember, this video's about to get banned in Russia.